The next order is a binding recommendation letter from the DNA subcommittee dated May 20th regarding the New York State Police's use of the TrueAllele technology. We have here today Dr. Dusman and Dr. Perlman from Cybergenetics. Any discussion?
Aren't they going to, I thought they were going to make a presentation about this.
The presentation was, and you got it provided to you, what was made to the DNA subcommittee, and then they're available to answer any questions.
Oh my God, well.
Since there's a binding recommendation from the DNA subcommittee.
I understand there's a binding recommendation, but could perhaps they tell us how this is going to change the presentation of DNA evidence in court, because it seems to me that this is not in any way trivial or insubstantial. I think I have some idea of what it is, but I think it might be helpful to share with everybody else, because this is kind of a sea change. And,
it is a big sea change, and if you like, I mean, I could spend 5 or 10 minutes talking about what the software actually does and what we see as being the advantages and why we want to use it. And then maybe if you wanted to, Mark, you could follow up with some of your courtroom experience to date, because it actually has been applied in courtrooms, although obviously outside of New York State. Would that work?
Please, 5 minutes.
Basically, the two things that I want to basically touch on is what the software does and what are the advantages it brings to both prosecution and defense. For us in the laboratory, basically what it does, it's soup to nuts. It does practically everything, but the key thing is it helps in deconvoluting mixtures. These are always, not always, but these can be very complex problems for our analysts to address and solve. And what's nice about the computer is it can address these problems automatically in a very objective fashion and return the maximum information. What it does basically is it takes the data from the genetic analyzer, applies a quality assessment of the data, and it converts the data into peaks, which is what our analysts are used to looking at. And then at that point, the analyst can interject. The analyst has an opportunity to look at the data, see if it agrees with what the computer sees, and if it does, or she does, the data can go directly into the computer. And there it resides until the analyst is ready to ask it or to query it. The analyst can then come to the computer and pull in case elements. Can pull in the evidence patterns, can pull in the suspect's DNA patterns, can pull in the victim's patterns, and ask the computer, for example, I have a case here, I have these evidence items, I have this victim, and I have a suspect. Is this victim and suspect included in that evidence? The computer will then solve for that question. And if the analyst is not happy with the answer, it can actually challenge the answer. You can go and say, I don't agree with your call on this particular locus. I think it's a 1213. And the computer will show him or her what the answer looks like based on that assumption. Now, what's really cool...
You're scaring me now. You're like, I can picture this guy arguing with this computer.
Yeah, well, there's been actually something scenarios very similar to that when you're starting out.
Well, before you move any further, when there is an override, so to speak, of the computer, or when there's a difference, is there some part of the protocol where this is made transparent, where the documentation of this is mandated?
Please describe it. I'm not familiar with the override that you're talking about.
I'm talking about the query where you can actually...
So you have data, correct? And so you begin with a crime scene. The laboratory transforms that into quantitative data, various peaks. So let me take a minute and bring you to where your question is. At that point, a question gets asked of the computer. That question does not involve any suspect, any database of suspects. It can't. It's simply looking at it. It could involve a victim if you believe that the victim is a potential genotype. And what the computer can do that a person can't do is it can try out every possibility. It can say, here are some peaks, there's a high peaks, low peaks at every locus, and the computer can search the space of all possible explanations for that data. If the peaks are here and you propose an explanation there, that is probability 0, if that's what you're finding. If the data have a complex pattern here, and the computer is starting with explanations that are where the data are across all 15 loci, and the extent that they're there, and combining them, there might be more than one explanation, but at every locus there might be 100 different allele pairs that could exist as a value for a genetic type of some contributor, right? The computer's assessing all of them. And if they're in typical mixed analysis, there might be 6 or 10 possibilities that are giving roughly equal probability. The computer's trying everything. Those things that best match the data, best explain the data, are given higher probability. This is normative science. It's like Google, right? You do a search over everything, you use probability, and of all the things that could be there, only a few things can be there. And to represent uncertainty, you have probability. And so higher probabilities are assigned to the most probable genotypes. Lower probabilities or no probability are assigned to those explanations that have no support in the data. When the system is all done, it tallies up what it has, and assumptions are made which an operator can make. You can say, what if there are 2 unknown contributors in addition to the victim? On the same data, you could say, what if there are 2 contributors? As in any standard likelihood ratio explanation, the operator is forced to state their assumptions. So the assumptions that you can make are there 2 contributors? Are there 3? Are we including the victim? Is there degraded DNA? Should we solve for that as well? There are about a handful of choices like that an operator can make. Should we run it longer? Is this a hard statistical search problem with degraded DNA and a 10% minor contributor with 3 control? Then you'd search longer. Those are the only sorts of questions an operator can actually ask. For explanatory purposes, which is what Barry was talking about, there are explain interfaces where you can see how well things are fitting and how well the explanations are working, but that doesn't affect the operation of the program in any way whatsoever.
No, my question's a different one.
Yes.
Right. My question is, you're looking at the data and you're saying, is it 2 contributors, is it 3 contributors, is it 4 contributors, and you're getting answers on how likely or unlikely those scenarios are.
You're getting genotypes out. There's no likely yet. There's no comparison made yet with the suspect. Correct. You can say, I'm going to run it 3 different ways. It's a computer.
Right. My question, a very simple question, is all the different ways that the analyst has queried the software, are those going to, and the answers, are those documented so that when one goes back and looks at the report that comes out, are those all going to be available?
In the computer database, all of those are available. So, for example...
That I know. I'm asking him.
Yeah, I think...
What do you guys actually... Do you understand what I'm saying?
Absolutely, but I think the searches that he was describing are maybe a little more complex than ones we're actually going to do. I don't envision using the computer that we're going to actually ask it more than 1 or 2 questions, and certainly those records, those printouts will be available and be in the case record. We're probably not going to ask it for 3 or 4. Typically, it's quite obvious how many contributors there are to a mixture. And if you get it wrong the first time, you probably got it right the second. So basically, we're only talking about 2 records typically, and those would both be included in the printout in terms of all the data that's available up to that point.
Do you have that report that was sent to the last subcommittee? In it, Dr. Duesman provided what the genotype report looks like, what the match report looks like. That was provided to the subcommittee when they made their approval.
Yes, sir. So that whatever is generated, it will be reported.
Let me just,
Please, Mr. Shea.
yeah, let me try and ask this a different way, make sure I understand it, so that in fingerprinting, different field,
Right.
there's a method of analysis called ACE-V, analysis, comparison, evaluation, and then validation. And one of the things that in that field is important, we've discovered, is that when you take the fingerprint known and you take the smudge latent, the first thing that you do is you do this analysis, and you have to write down what you did, right, to document that step. In fact, this commission has had, over the last 3 meetings, several labs that have been called on their failure to document each step of the way that they do. I think that's the question Barry's asking. The question I want to ask you is, let's assume it's you. You're the gentleman who's talking to the computer, and you say to the computer, here are 2 assumptions. Here's assumption number 1, here's assumption number 2. Okay. 10 months later, I'm preparing this case for court. All right? The DA turns over to me, or you turn over to me, all the scientific evidence. When I look at page 97 of the 700 pages you give me, on page 97, am I going to see, these are the 2 questions I asked the computer? That's my question.
We can, absolutely, we can provide that. I mean, that's not going to be an issue. We had not actually thought that through, but it's a very good point, and it really shouldn't be an issue.
Well, what we've learned, I mean, just even take a look at the things that are going on with fingerprinting, right?
Right.
And the suggestion being made that first the analyst would read the prints, would look at the latent, and decide how many minutia are there and count them up, right? Then you look at the target, and then if there's going to be any change in the number of minutia that you count after looking at the target, you have to document those changes and give an explanation. So, so that kind of cognitive bias issue that arises in all these technologies should be transparent and documented here.
However,
That's the first step.
However, in most forensic technologies, as you're familiar from the NES report, forensics is often done in a way that can admit cognitive bias because a comparison is made between data and a suspect. That's a concern, and I'm sure you've written articles on it, if not read many of them. With modern computer interpretation, what's possible is to never look at a suspect. Now, what the advantage this has is that regardless of the assumptions that you're making, are the 2 contributors that degraded, whatever, and the result might be a different in match score of, 10 trillion versus 100 trillion. That's what you're talking about when it's all done. That interpretation cannot be biased the way a person might by looking at a suspect, because it's impossible for the computer to see the suspect. The question makes no sense to it. It's fully documented in the operation of the computer. It had the data. This was a suit. So the issues that arise in fingerprints of making sure that you're not biased by looking at what the answer might be can't arise when that genotype is inferred by a computer and a comparison is made to 1 suspect or 5 suspects or to an entire CODIS population of suspects. It never had any idea what you were looking for. It was just inferring what genetic type information was present in the data.
If the analyst is asking the computer a question in our hypothetical, which I think I agree with my colleagues should be disclosed, but the question, does the analyst know the genetic profile of the suspect, of the victim?
That's operationally of how you would run the software, and that's up to the lab's procedures. But the computer's answer is not affected by what an analyst may. An analyst may ask the computer to work on it longer, harder, whatever.
Right.
But whatever the analyst might know can't affect what the answer the computer gives is.
But it might affect questions.
Right,
the analyst.
exactly. That's my question.
And that's a workflow issue, and that's one of the things that we, workflow model that we want to make sure that we ensure is that the objectivity is maintained. So those control samples are going to go, into an automation process and directly into the computer. The only role of the analyst will be to assign them to that automation process. They won't have a prior look at the analyst profile.
The last trial I had with Russ Gettig was a mixture case.
Yes.
And one of the many things that made Dr. Gettig's testimony attractive to the jury was his lack of knowledge of the profile of the suspect and the victim prior to his test. So if that were the case here as well,
Yes.
that would help my presentation to this court.
That's an excellent way of running it, and the software is set up to accommodate that workflow.
Right, I mean, one can see the advantages, I mean, it's
And would make
replicating.
Barry's job more difficult, and I forgot to point that out.
It would make Barry's job much easier if the person wasn't in there.
Question of bias from
No,
the
no,
board, which is part
you
of
have
our...
to understand what my job is. So the, you know,
Just seeking the truth, Barry, I know, please.
I would have thought after all these years you'd done that. But, no, I understand the notion that this can be used in a way where it's replicating essentially sequential unmasking, right?
Exactly.
You don't know, so
It
you're not
predated
biased.
sequential masking.
I'm sorry?
It predated sequential.
Right, but what I don't understand about this, and you know, I understand that the DNA subcommittee, you know, it's binding, et cetera, but that doesn't, I think it would be nice to have a more detailed explanation at some point of what this is, so we can understand how this gets implemented operationally. How do you, this is, I'm familiar that different laboratories will validate a different cutoff point, right, in terms of RFUs for deciding whether to call a particular allele as real or not real, right? And you're saying things like, well, ask the computer to work longer if there's a possibility of degradation. My understanding from just reading what I got here in this report was that you're looking at the data that you get, right? The computer program is, right?
That comes from the laboratory.
Right, that comes from the laboratory. And so in cases where you have peaks of certain relative heights, right, the computer will be making a qualitative assessment, right, based on all the different peaks. And you're not necessarily...
Quantitative assessment.
Well, quantitative assessment, but you're making an assessment based on all the data that's there.
Yes.
You're not simply saying, oh, that one is below 50, therefore we don't count it.
That is correct.
This one is below 100, therefore we don't count it, which is the way other labs, the FBI, for example, have been doing it, right? Under the theory that this is going to cut down on the number of cases where you might incorrectly call something as real when it is in fact an artifact.
Absolutely.
Right? So, how have you validated this to make sure that your alleles are true as your, I guess?
Can I give one quick answer before Barry talks about the
Single
validation
most asked
studies?
question, so go ahead.
About 20 years ago, when people were working on statistical computing, there was a realization made in a paper in 1990 that assessing the certainty or the uncertainty of your data was something a computer could easily compute. As statistical method, as the computer, it's taken 40 years for computers and statistical search for people to realize what you can do with them. But what happens, what is the purpose of a threshold? It's to say, what certainty do I have that I can account for this? What's really happening is that around every peak there's a bell curve of some kind, and you're trying to draw a line through it. What the computer does, in essence, is it figures out from the data, using standard statistical methods, what is that bell curve around every peak? So it's steroids, it's thresholds on steroids. It's doing it for every peak based on what the data is trying to tell you. So that's why you don't need thresholds if you let computers loose for 8 hours on these problems and they're doing this measure of statistical search. They work out the certainty or the uncertainty of every peak in the data based on the data. That's modern computation, and that's what we expect from our computers nowadays. So that answers, I hope, your first question. That's what computers are doing to, in a very strong way, replace the need for thresholds in a much more reliable way. It respects probability and determines what those distributions are. But Dr. Houston, do you want to talk about the validations, or?
Go ahead.
Okay. So a number of validation studies have been done based both on synthesized experiments as well as casework experiments. NIJ funded validation studies on TrueAllele and mixture interpretation 10 years ago, which I had the opportunity to present last week at the NIJ meeting. And with those studies, which were published in 2009 in the PLOS ONE journal, a comparison was made on mixtures of how much information was obtained from each mixture reproducibly. Everything was done twice, so the reproducibility of the computer was measured under different methods and then compared with people. The exact same data as scored by threshold methods. And what was found was that from this paper, as a result, is that if you look at the quantity of DNA on an order of magnitude scale, 10, 100, 1,000, and you look at how much information was there, the likelihood ratio, you know, a million, a trillion, and so on, that the computer, looking at all the data, showed that as the amount of quantity of DNA went down, and you hit about 100 picograms, so people stopped looking at the data, you could see a straight line, and you could see how much information was obtained based on the amount of DNA, and people were shifted over by a factor of 10. So that was the first published study of what was found in a peer-reviewed journal. In a paper that's appearing in Journal of Forensic Sciences this fall, 2011, in your second newsletter, you're looking at some of the diagrams from there, and a comparison was made on actual cases, adjudicated cases in New York State. There were 8 cases of two-person mixtures where there were 2 unknowns and no victim was available. And then there were another 8 cases, again, of 2 unknown mixtures where the victim was available and used of the interpretation. And so we had the computer make the same assumptions that people did. And I think, I don't know which slide it is, but if you look at the one where it's 2 unknown, what happened is that the computer ran it twice, was found to be quite reproducible, with virtually no variation in the match statistic. It's essentially the same. And then comparison with human review using accepted threshold methods on the identical case data showed an average difference of 1 million in the match score. Now, the reason for this is that quantitative methods preserve the identification information that's present in the quantitative data better than putting thresholds through them and discarding the quantitative data. So, and then a similar comparison was made in this validation study on 8 cases where the victim was known, and there the difference was about 50,000 in the match score.
Has anybody critiqued this method?
It's been...
I know, but I mean, has anybody, let me be clear, has anybody published anything or presented anything that's critical of this methodology?
Not that. What I do know is that there are groups, particularly in Europe, that are publishing papers that are making available simpler forms of these methods that make the same assumptions that the quantitative. There's a paper out of Denmark and a thesis that came out that's quite popular. There are groups in England and Italy. There was an excellent paper out of New Zealand 2 years ago by James Curran that used the same assumptions, the same sort of statistical computing, and reached the same overall conclusions, which is using all of the data, using modern probability, and using probabilistic computing, preserve most of the information that's present in the data.
Mr. Schechter, you have a question.
That's actually been answered. Thank you.
Okay.
And in the SWIG-DAM guidelines that came out last year, paragraph 3.2.2, SWIG-DAM and the FBI acknowledged that probabilistic genotypes were a fine way to interpret mixtures, with the proviso that a validation study would be done by the laboratory before they were used.
At this point, we have this binding recommendation from the DNA subcommittee recommending approval of the TrueAllele technology and its use by the New York State Forensic Laboratory. Is there a motion on the floor to accept the recommendation of the DNA subcommittee?
I'm sure that this is brilliant, but I must say, I found what I got here, right, these reports, insufficient to understand. I don't completely understand this methodology. I really don't understand how this is going to be validated, what it's going to look like in a laboratory level. I don't understand what the printouts going to look like and what the expert's going to be testifying to. I very much welcome the theory behind this, because it sounds to me like an improvement, but I'm fairly clueless about this. And
That's why we have the statutory delegation of the responsibility here to the DNA subcommittee, so that they could delve into these matters and determine whether or not they are scientifically valid.
well,
Barry, don't you anticipate that, I mean, it hasn't been presented in court yet.
Oh, it has, in Pennsylvania twice. It testified earlier this month.
Not in New York.
Not in
Don't
New
you
York, yeah.
anticipate a Fry, Dauber, whatever hearing?
well, you know, I'm sure that whatever is presented is going to be challenged at some point, and they'll have to defend it in court. And, by the way, I noticed that Dr. Duesman and Dr. Perlin, that you both are, you both published this? Is it based on
There's a
your joint research?
publication in October in Journal of Forensic Sciences based on the research that we did.
Right. And who has patented this technique? Or is it patented?
Actually, many people have filed patents on this technique across the world of quantitative interpretation. We're one of the many people who have filed patents, but there's no value to them. All they say is that you use quantitative data.
But and I mean, no disrespect. Is there any, will all of New York State be paying for some particular computer program? And if so, who gets the money and how much is it? Or is this, just asking?
The development to date has been largely supported by the National Institute of Justice and the New York State Police.
Right.
So we anticipate...
I mean, does that mean that it's a public license and nobody makes money off it if everybody adopts it?
It turns out that most of the cost of delivering this technology is to educate attorneys like yourself and to educate crime labs in new ways of working. And so the support that's done is for validation studies and a tremendous amount of education. At this point, the best model for that has been a commercial model because there's no federal funds to pay for that.
It will be very similar to what we did with the Convicted Offender Data Bank. That the program that we used there to evaluate or assess the quality of the data for the Offender Data Bank was an offshoot of this development. And so we brought it online, and then we pay a licensing fee every year to Cybergenetics.
But it is a proprietary software package that you have purchased from Cybergenetics.
That one, yes.
And how much, can it be disclosed, how much is being paid and who's paying for it?
I don't know.
What's to be expected?
A typical, I'd be happy to make this statement for you. A typical system that a laboratory can use and get started with that would solve their mixture problems is about the cost of one DNA analyst for 1 year. That's about the cost of a starting system. But the question you're asking is very difficult. It's like, what's the cost of a legal defense? It depends on the scope of what a laboratory wants to do. Laboratories have spent $30,000 on it. Laboratories have spent $300,000 on it. It's what they want in terms of education, training, certification, validation.
And on balance, I would say...
I don't understand. I mean, are you saying that the software program must cost, a license for that must cost something? And then, what?
He just told you that cost.
It depends on the size
What it
of
costs
the
to
lab.
pay an analyst for the year.
What does it cost to pay an analyst for a year?
$100,000.
$100,000?
With benefits.
With benefits and so. So the answer is $100,000.
Is that what it costs?
Per year, or just?
No, that's for a system.
To buy the system.
Many laboratories like support.
Right.
Right.
So you would have to pay $100,000 to buy the system, right? And then it has to be validated.
And then you spend the time
and then you have to,
to
and then
It's like a DNA sequencer. A DNA sequencer costs about $100,000, and you have to buy it, you have to validate it, you have to do work with it.
Is there some way to average that out for our laboratories in New York State? How much it's anticipated would have to be paid for each of the laboratories, A, to get licensed the software, and B, what would be expected? Is it just $100,000 a
They'd have to
year?
buy
It
a
just,
system.
it depends on what a laboratory wants. I can't tell a laboratory, I don't make policy for laboratories. If a laboratory wants to spend $35,000, they can. If they want more training, support, help, certification, and so on, we don't deny it to them.
No, I guess, look, I'm not really being accusatorial. These are the questions that anybody would want to, is there some way to estimate how much this is going to cost the labs that are currently doing business in New York, given the output that we have, and what are the anticipated costs in terms of training
Well, there's
support?
first of all, there's no guarantee. I think that every laboratory in the state is going to want to use it. I think right now we have 2 laboratories that are very interested in using it.
Right.
The other consideration, I think, is
That
actually
being
a
the state
cost.
police and who else?
Suffolk County. Yes.
Suffolk County?
But it's more of a cost-benefit issue. For example, in the data bank where we've instituted this program and all the data flows through there, we've actually been able to roll 6 staff members out from the casework because it got to be that our throughput and our capacity far exceeded what our case inflow was, that we've been able to roll people out. So there's 6 positions right there that no longer are needed in the data bank. And I anticipate a similar situation.
But the way this is being used now in the data bank, I take it, is that this is a software that's being used to assess mixtures.
No, the data bank is just data quality. Data quality.
Data quality?
Yes. Yeah, we don't run into mixtures in the data bank. Those are all single source.
Convicted offender. He's done convicted offender.
Convicted
offender.
No
Yes.
mixtures.
Oh, we're not, you just
I'm
about the
sorry,
quality of
convicted
the
offender.
convicted.
Yeah.
I'm sorry.
Yeah.
Okay.
Most groups see a productivity gain and a cost savings by bringing a system in.
Look, this is all fascinating. It sounds like it's extremely important. I recognize that these are quote-unquote binding recommendations, right? On the other hand, I sure would like to have a presentation on this so that I can actually see it concretely and I can understand it. And I say this because I don't, right, in the kind of detail that I think would be helpful to me. And I say that, and look, I know something about this, right, from the point of view of a lawyer. So if I'm having trouble grasping this, I've got to believe that everybody else is, okay? And I just want to understand it concretely. It may well be that, it's all binding, therefore it doesn't mean anything, but I don't understand it. At this point, and I really want to understand the money, and I want to understand where the money's going to go, and how it's going to save us things, and I anticipate that it's going to be great, all right? But I don't want to just sit here like a potted plant, saying, oh, well, this is all wonderful, because I don't understand.
Mr. Schechter?
Just a matter of procedure. What does it mean when we have a binding recommendation?
We can accept the recommendation, or we can return the recommendation to the DNA subcommittee.
And we could also adjourn this discussion for further information, right? If the recommendation still stays the same, a binding recommendation, and we can hold off, correct? And if we don't touch the recommendation, we just put the discussion.
I think at this point, we're confronted with a vote up or down on the
Really?
binding recommendation.
Is that a procedural issue?
I think
or-
it's actually in statute.
Really?
Well,
I don't know, we can return it. If we don't agree with it, we can return it to the DNA.
That would be the procedure.
Right.
So if it
but look, I don't understand this, and I'm sure I'll like it when I understand it, but this really is not an adequate,
Did you get the slide?
There was a presentation that was provided.
yeah, but it's not the same as having somebody present it as follow-up questions to understand it. Do you understand this all?
I understand it's a statistical computer program that I'm not going to understand, so...
Well, see, I have greater hope that I can actually, I don't understand statistics that well, but I sure understand how things are analyzed, presented in courtrooms, and I know I know this is a very important topic. I know that this is absolutely critical to making or not making cases involving mixtures. I know that there's 3 or 4 different ways that people testify as to mixtures. The statistics are wildly varying. This looks to me like an extremely helpful, potentially objective, cost-saving, labor-saving technique.
I vote yes, damn it.
And I have no idea how it's going to work, and I really would like an opportunity to have it presented before we, so I'm going to have to vote not to accept until I understand it. And I got to believe that, you know, I don't know, maybe Kathleen, maybe you have a
What if you never
understand detail.
Mr. Schechter?
I would just simply, if it's up here for a binding vote, I guess no motion's in order. I suppose I was going to make a motion that says, let's return this binding recommendation to the DNA subcommittee for the purposes of that subcommittee setting a date certain for a presentation for any member of the Commission on Forensic Science who wants to attend, and then have this on the agenda at the next meeting for us to vote on.
Actually, that has already
There was
happened.
already a presentation
And the
to the
president-
DNA subcommittee, and that...
To the DNA subcommittee.
Correct, and that
Right.
presentation was provided to all members. It was emailed to everyone.
Well,
Okay.
this is much too complex to understand by that process.
I mean, I think the issue that I see, you know, whether or not everyone at the table understands it completely, the DNA subcommittee is the group that vetted this out, and they gave us the recommendation. They are the experts for DNA issues. So, you know, my feeling is if they're okay with it, I don't know that anything that we can hear is going to change our opinion.
Well, that's not true. There are issues of cognitive bias, there are issues
None here.
of... But, no, I understand. You're telling me that there's no cognitive bias possible here, because all the peaks all the likelihood ratios are determined by computers. And you're telling me also that there'll be complete transparency, because every query made of the system is going to be documented and we'll understand it, all right? I don't understand, I'm very, very concrete. I'd like to see it so that I can understand it. I'd also like to, I also want to follow the money, and I want to understand who's making money off this and who isn't making money off this, and how that works. No, and I don't mean that because I'm going to be asked that question. We're going to be asked that question because this is potentially an extraordinarily important development in this area. I recognize that. And so I'd like to understand it. It is not sufficient for me to just get a slideshow by email and understand it. And it's not good enough, frankly. It shouldn't be good enough, I would hope, for most people in the committee to just say, well, they're the experts. I'm incapable of understanding in some detail exactly what this means. That shouldn't be a good enough, that's not a scientific response. That's not a legally sound response in my judgment. And I really, I don't mean to be offensive about this, but I don't understand it. And I've got to figure that if I don't understand it in any nuanced way at all, that I can't be alone. Because I actually understand something about this subject.
So at this juncture, we have a binding recommendation before us. We have a number of board members that have suggested putting it over. Do we have a motion to accept the binding recommendation from the DNA subcommittee?